Good afternoon, guys. This is Professor David de los Reyes. My topic this afternoon is still plane areas, but it will be under parametric equations. Okay, let's proceed. This will be my last topic on plane areas under integral calculus because my next discussion is the computation of volumes under integral calculus. After volumes, I will be continuing with my mathematics lecture, and that will be the topic differential equation. Differential equation is actually the prerequisite is differential calculus and integral calculus. So after volumes under integral calculus, I will discuss differential equations as a complete course also. Okay, let's proceed. Lesson number 59 under integral calculus on my channel, plane area. This will be under parametric equations. Plane area, we now discuss, or we have already finished plane areas under the Cartesian coordinate system, plane areas under polar equations or polar coordinate system, and our topic this afternoon will be still plane areas, but this will be under parametric equations. Okay, I will give you an example problem on how to compute plane area involving parametric equations. Parametric equations is something like this. It will be x as a function of theta and y as a function of theta. Okay? X and y are Cartesian, but the right hand side is in terms of a trigonometry. So this is actually referred to as parametric equation. That is, x will be given as a function of theta and y as a function of theta. Okay, I will try to read the problem. Find the area enclosed by the parametric equation. The first parametric equation is x equal to 2 plus 4 sine of theta. And the second parametric equation is y equal to 3 minus 2 sine of theta. The problem is asking for the area enclosed by the given parametric equation. So for the meantime, we do not have any idea on what will be the graph of this. Okay, it's a parametric equation. Will it turn out to be under what they call this polar, or will it turn out to be under the Cartesian thing? Supposed to be, I think it will pull under the Cartesian coordinate system because this involves x and y. There's no radius. Okay. So for this, we must have to eliminate theta here to produce an equation involving terms of x and y only. If it involves x and y, this falls under the Cartesian coordinate system. Okay, let's proceed. From x equal to 2 plus 4 sine of theta. We are given this, right? Solving for sine of theta from this, 4 sine of theta will be equal to x minus 2. X, we transpose this to the left, we rearrange. 4 sine of theta will be equal to x minus 2. Dividing both sides by 4, sine of theta will be x minus 2 all over 4. Squaring both sides. The square of sine theta is sine square of theta equal to the square of the right hand side is just the square of the right hand side. Okay? So it will be x minus 2 quantity square all over 4 quantity square. Okay? You can double the numerator separately with respect to the denominator also separately. Or actually, you could just remove this one and this will be under quantity square. But I've got a reason why I segregate the squaring of both the numerator and denominator. Later on, I will show you why. So this is x minus 2 quantity square over 4 quantity square. Equation number 1. From the given second parametric equation, y equal to 3 minus 2 sine of theta. It is this. Solving for sine of theta, 2 sine of theta, we put it on the left. Okay, then we transpose this on the right. Therefore, twice sine of theta equal to 3 minus y. Okay? Then, dividing or multiplying all terms by 1/2, we multiply by 1/2. Okay? Left hand side, this will cancel out. So what remains on the left hand side will be sine of theta. Right hand side, it will be 3 minus y all over 2. Okay? Then try to square both sides. The square of sine of theta will be sine square of theta. The square of the right hand side will be, again, I will square both the numerator and denominator separately. So it will be 3 minus y quantity square all over 2 quantity square. Why there is 2? There is 2 because we multiply the right hand side by 1/2, right? Okay. Okay, proceeding with the solution. Adding 1 and 2. Equation number 1, x minus 2 quantity square over 4 square, okay, plus 3 minus y quantity square over 2 quantity square equal to. Upon adding this, I just put the x and y on the left and the trigonometric on the right. So this will be equal to cosine square of theta or sine square of theta plus cosine square of theta. Actually, I just add this one, guys, this one. Right? So the right hand side is this, or left hand side rather, and the right hand side will be sine square of theta plus, hold it, for sine, cosine. Sorry for this one, guys. This should be cosine. There is a syntax error here. Cosine of theta. Sorry for this one. Cosine of theta. So this is actually cosine of theta. So this is cosine square of theta. The first one is sine, the second one is cosine. This is cosine, right? It's just a syntax error. So, adding the right hand side and rearranging x minus 2 quantity square plus 4 square is this. Right hand side of the second one is 3 minus y quantity square over 2 square equal to, right hand side involving the trigonometric is sine square of theta plus cosine square of theta. Okay? But this is 1, right? So it will come out as x minus 2 quantity square over 4 square plus y minus 3 quantity square over 2 square equal to sine square of theta plus cosine square of theta is actually 1. This one. Okay? Why I place this as y minus 3 instead of 3 minus y? Okay, I will show you the proof that this one here is same as this. It is this. Originally, 3 minus y quantity square, I place it as y minus 3 quantity square. I said they are equal. Okay, let's bring out the proof. We square this one. First term will be y square. Middle term will be minus 3y times 2, that is minus 6y. Third term, the pure constant is minus 3 quantity square, that is plus 9. Is it equal to? We square 3 minus y quantity square. Because I said that 3 minus y quantity square is equal to this. So let's try to square this one. First term will be 3 square, that will be 9. Middle term will be 3 times minus y is minus 3y times 2, that is minus 6y. Third term is minus y quantity square. Negative. We square that one, it will be plus y square. So if we try to rearrange this one, y squared minus 6y plus 9, I just rewrite it. Is it equal to? I will write this one first, y squared minus 6y plus 9. They are equal, right? They are equal. They are equal. So actually, 3 minus y quantity square can be written as y minus 3 quantity square equal to 1. And this is similar to, if you try to recall your analytic geometry, this is similar to the form x minus h quantity square over a square. This should be plus y minus k quantity square over b square is equal to 1. This is actually an ellipse. Okay? If this is plus, okay, it should be an ellipse. If this is minus, it should be a hyperbola. Okay? The value of h is actually this one, 2. H is equal to 2. This minus 3 here is actually k. Meaning, the center of the ellipse is at 2 and 3. 2, this is 3. That's the center of the ellipse. This is 2 and 3. Right? And what is a square and b square? A square is actually equal to 4 square. Therefore, a is equal to 4. The major axis is 4. And b square is equal to 2 square. Or b is equal to 2. Minor axis is equal to 2. So I place it here. This equation here is an ellipse with center at 2 and 3. The value of the major axis is 4 units. And the value of the minor axis is 2 units. This is 2 units. And this is 4 units. Okay? This is the major axis, the longer one. This is the minor axis, the shorter one. This is 2, this is 2, this is 4, this is 4. And the equation of this one is this one, the one with the rod. So if we try to recall the formula on how to take the area of an ellipse, we derived it already, guys. It is pi AB, right? Right? From the polar coordinates. So the area now will be pi times 4 times 2, or the area will be 8 pi square units. And the graph is this one. Y-axis, x-axis, 1, 2. Okay, that's the abscissa of the center. The ordinate is actually 3. 1, 2, 3. This is 3 units. So this is 3 unit high, this is 2 units high, and this 2 and 3 here represents the center of the ellipse. This is, the major axis is actually 4 units. This is 1, this 2, 3, this 4. 1, 2, 3. It should be 4. 1, 2, 3, 4. 4 units, 4 units, this is 2 units. 2 units. 2 units. That's it, guys. That is an example of the so-called computation of area under plane areas if it involves parametric equation. Meaning parametric equation, we are given x in terms of theta and y in terms of theta. So for the meantime, try to use your knowledge of algebraic manipulation to bring out an equation that involves x and y. Actually, this is the final result upon the usage of the so-called algebraic manipulation. What comes out now will be an equation involving x and y, and if it comes out, you've got a problem. You should visualize it. Will it be circle, an ellipse, or any other thing? Okay? And since this is an ellipse, we now know the value of A equal to 4, B equal to 2. We know the center. So this is the graph. We know the major axis to be 4, minor axis to be 2. So the area will just be simplified. AB, pi times 4 times 2. Area will be 8 pi square units. Okay, good afternoon, Los Angeles.